Hey, Vinny. What are you doing? You're twiddling.
Listen, I haven't twiddled my fingers in 13 years. You took those privileges from me the day I stepped into this family.
I says, hey, Vinny.
How you doing, Artie? I hear we have a small problem in the family.
Yeah. I mean, the school, they're spending too much money. I mean, our recycling system is horrible. Everybody's leaving the lights on, using all the water. The AC's always on.
Hey, we tried everything.
Everything. I mean, we tried yelling at these kids.
Yelling at them.
You know what I have to do now? I have to put my hands in it. No, you have to put your hands in it.
It wasn't one of my best days, all right?
No, Donnie didn't bring you coffee. We had a failed hit that week, for Christ's sake.
What about the time we put a little guy in the trash?
So what else do they want?
What else do these people want?
Little guy.
Yeah, I'm scoring 35 out here.
That's it! But I honestly think we overpaid him a little much.
Yeah, we ended up getting the short end of the stick.
You know, it didn't even work.
Yeah,
Through all the effort he put out. He was very enthusiastic. It didn't even work.
I mean, we went to the lowest point, too. I mean, you had that crazy idea of getting 5-0 involved. Jesus.
Excuse me, young man. How you doing today? What's going on? What was that you just threw away in the garbage can? Oh, that's recyclable, you know. Can you go ahead and grab that out of there for me? All right. You know what the fine is for recycling? It's $219 under Connecticut General Statute for recycling. Okay? Do me a favor and stand over here. I'm going to grab my ticket book and write your ticket, okay?
Oh, you too?
Understand, that wasn't one of my finest ideas. I
Forget
appreciate you keeping me here with me.
Forget about it. I mean, what about that time we tried to conserve energy?
Guys, everybody's going to take a quiz here today. I want you guys to identify the following parts of a stringer.
All right, party's over. We need to save some energy, all right?
Come on! Hey, what are you doing?
Hey, we can't see.
Let's go. Get out of here.
We can't see, really?
You know, I couldn't believe those kids couldn't work in the dark.
Apparently, you need lights to learn.
You don't.
What about the time tried to save water?
That was something.
Hey, yo, whoa. What do you think you're doing? What are you, thirsty? I'm thirsty, man. You crazy?
You have your own water at home?
Get out of here.
Listen, nobody ever told me he ended up going to the hospital.
What do you mean he went to the hospital?
He went to the hospital after that.
He went to the
Dehydration.
Oh, you need water now? I think we need some professional help.
Let's see what they have to say.
Hi, I'm Deanna, and this is my partner, Kevin. And we're presenting water conservation. During our investigation, we found that all the sinks and drinking fountains, toilets, and urinals are already efficient. However, today, you can get more fixtures that make them more efficient.
Our current lab aerators in our labs, they run at 2.2 gallons per minute. We have aerators in our laboratories that reduce the water flow to 1 gallon per minute. So this helps to slow down the water use. Our current drinking fountains run at a ½ gallon per minute. We need to make sure that the water fountain screens are not clogged. If they are clogged, they may restrict the water flow and we use more water. The current toilets, they run at 1.6 gallons per flush. We can purchase more efficient toilets. Recently, a toilet that uses 1.28 gallons per flush came out. That doesn't seem like a big savings, but over the time of a year, it'll amount to a lot of water and money saved. Our urinals, they run at 1/8 gallon per flush. This will save an average of 85% per flush. So we should get more efficient urinals also. Our waterless urinals, you can get a waterless urinal that uses chemicals to maintain odors rather than using water. So it'll totally eliminate the water from the use. So this will save a lot. And then there's preventative maintenance. It's a good way of maintaining water efficiency. So we would troubleshoot all the sensors in our water, the sinks, the toilets, and the urinals. Because we noticed that in shop, sometimes we'll be in the classroom and no one's outside and the sink will go on. So the sensors may be faulty, so we need to maintain them and make sure that they're running properly. And we came up with the Rainwater field project. It would reuse the water from the roof, like the rainwater. We would filter it and use pumps, and we would make it so we could water our fields during the season, and it would save an average of 300 gallons per day, totaling 12,000 for the sports season, and that would save a lot of money and water for our school.
You know, I find it pretty unbelievable how much money we've been spending on water every year.
Meanwhile, we could have been mixing our cement shoes with rainwater. It's unbelievable.
You know, let's see what these electricians have to say.
I'm Ultraviolet, this is Mark and Tom. We're from electrical and we did the energy investigation. Recently our school was renovated and some of the features added were high efficiency light fixtures and occupancy sensors in all the hallways and classrooms. To start our investigation, we first researched our school's electric utility bill, and in 2012 the annual cost was about $490,000. To find the monthly average, we divided that by 12 and found that it was about $40,000 per month. This sparked our interest in where all the money was being spent.
So we all banded together in 4 different groups to find out exactly where the energy was being wasted inside the building. With our photographer that documented all the events that occurred during the investigation, the natural light group, which checked all the natural light and artificial light that is being projected inside the room to see if it's adequate, the artificial light group, which checks each fixture and light bulb inside each room to see if that is being adequate, and the appliance and device group, which checks each equipment that you plug into the wall to see if the power being drawn from it is being adequate.
A watt is a unit of measurement used to calculate how much power an appliance or device uses. And in our investigation, to calculate this, we used a watt meter. And what the watt meter does, it multiplies the appliance's current by its voltage to come up with how much power or the wattage of the appliance or device.
But using a watt meter on a large appliance is impractical, so what we did was we looked on the nameplate for the current and voltage, and using our pie chart, we multiplied them together to find power that way. The natural light group used a light meter to measure if the lighting was adequate around the school, and we did this by placing it on a desk near the window, away from the window, and in the middle of the room. And we took measurements with the lights on, with the lights off, and if we could, we did it with half the lights on.
After we finished the investigation and compiled all the data together, we figured out that the only problem inside the entire school was that the computers and monitors only had sleep mode, which meant they never shut off all the way. The lights in the hallways already had enough natural light from all the windows that were being installed, so there was no point even having the lights on. And the parking lot lights, the light bulbs, were just using way too much energy to even begin with.
This here is our school-wide lighting chart. It shows all the light bulbs that we calculated throughout the entire school. We use 7 hours per day on average, because that's how long approximately our school days are. We use 10 cents per kilowatt hour, because that's around what the kilowatt hour price is now. And we use 182 school days per year. And we multiply this together and we got our annual cost for electricity for our light bulbs that we calculated.
We decided to focus on the school lighting as an area where we could save the most energy and money. And this is a picture of our main lobby, and as you can see, there's enough natural light coming in from the wall of windows that we don't need to have the overhead lighting on. And after taking measurements, we found that it was 163-foot candles with the lights on and 140-foot candles with the lights off, and that's still over what it needed to be for a main lobby. These are 3 hallways in our school, and for a hallway to be considered adequate in lighting, it should be about 25-foot candles. The measurements we got were way above that, so we decided we didn't need to have the overhead lights on all the time. So our solution to this was to install an occupancy sensor as well as a light sensor, so if there were students in the hallway but there was enough natural light, the overhead lights would turn off. We decided to change our target to the parking lot lighting because that was an area where we could save even more money and energy. Currently we have 175 watt and 400 watt metal halide bulbs. Our solution to this was to switch to LED bulbs. LEDs are better because they use less energy, they last over 7 times longer, and they don't produce harmful UV rays.
As Violet said, we only have 175 and 400 watt metal halide bulbs inside the parking lot. So what we did was that we went outside into the parking lot. We counted up each light bulb that was inside the whole thing. We calculated that it was on for 12 hours because that's kind of how long a night is over here. We use 10 cents per kilowatt hour because, as Tom said, that's the average that we spend on electricity. And since it's a commercial building, we spend our annual amount on 365 days because that's how long a year is.
This is a comparison chart between the lights we have now and the lights we could have. After contacting a distributor, they suggest we purchase 32-watt LED bulbs for the 175-watt metal halide bulbs and 126-watt LED bulbs for the 400-watt metal halide bulbs. Currently, our annual cost for the parking lot lighting is around $9,000, but if we purchase the LED retrofitting fixtures, it would be just around $2,000. The initial cost of all the fixtures would be around $25,000, but with an annual savings of over $6,000, the payback would be in just 4 years.
You know, $6,500 a year, that's unbelievable. What were you doing thinking of installing all those lights? Why don't you shut off the lights every once in a while, huh?
We're gonna have to find whoever installed those lights and give them a good talking to. You know what I mean?
Seems like you got another job. Alright, so apparently carpentry's been doing the trash.
How are you guys doing today? My name is Michael Ortiz, and this is my partner, Kanai Tatum. And this is our class, it's carpentry department, and we've actually been working on the trash and the recycling. So at EC Goodwin, we have 5 separate dumpsters, and 3 dumpsters are for waste, and the other 2 dumpsters are for recycling. One is for cardboard and paper, and the other is for strictly metal.
For waste pickup a month, we spend $1,770, and for recycling, we only spend $620.
So we run around our school weighing all the recyclables and all the trash from all the classrooms, and we came back to our classroom and calculated everything that we have and all the pounds, and we actually came up with the total amount for the day, and the waste was 335 pounds, and the recycling out of that was 152 pounds.
While picking up trash and recycling, we asked some people why they don't recycle, and the reasons they came up with was the system was way too difficult, we don't recycle plastics, and that they had lack of information, and one thing was they were just way too lazy.
We came up with a solution about that. It's called single stream recycling.
Single stream recycling is basically taking all recycling materials such as plastic, metal, and paper and putting it all in one recycling bin instead of separately. This makes it easier on us.
The cost for all this that we're doing is $1,470, and in the cafeteria we will need 2 bins, and the total of that is $180. So each bin is going to be $90. And we have 60 classrooms in our school, and each classroom will need 1 bin, and each bin costs $10, so come out to $600. And for the maintenance to pick up everything is $690, and each bin is $230. And we need 3 of them. And the monthly cost for all of this is roughly the same amount that we've been doing now, that we've been paying now.
The benefits of single-stream recycling is that it's an easier system, it eliminates 1 dumpster, it's eco-friendly, and that we're recycling plastic, which is one of the most minimal recyclable material that the earth needs. Thank you.
You know, I find it pretty awful that we could have been recycling this entire time for almost exactly the same cost of what we're doing now.
Unbelievable. It makes me sick to my stomach. We don't even recycle plastics. Jesus.
Go ahead and see what these HVAC guys got.
I'm Alberto. These are my partners, Jeremy, Devin, and Sean. We represent Connecticut Clean Trades, and this is the HVAC investigation team.
In our investigation, we used tools such as thermometers, relative humidity meters, CO detectors, and measuring tools.
These are some pictures of us checking the temperature, taking the square footage, and us logging our information.
We calculated building loads and losses. We took our gross walls, we subtracted our windows and doors, and calculated our net wall.
This is a chart that depicts square footages and calculations of the school, and as you can see, our school is roughly 250,000 square feet.
This is a bar graph information we just saw showing running exposed walls and geographical locations of windows for solar gains and losses.
Some problems with our building envelope is that our block exterior walls are uninsulated.
a massive 150,000 square foot roof has minimal insulation. Our air infiltration is very low. There's no trees for shade coverage, and there's high ceilings and no ceiling fans.
EC Goodwin's roof has an R value of 13.5, and the average home built today has an R value of 30 in its attic.
EC Goodwin's building envelope is constructed of concrete walls. Our walls are 8-inch thick, and the R value in our walls is 1.35. The average R value in homes today is equivalent to R19.
To calculate heat losses and heat gains, we will calculate the room volume in cubic meters and divide that by 20 to get heat in kilowatts, and that's an example of that equation.
In order to calculate the total BTU load, we took the square footage and multiplied by the average ceiling height, and we came up with 4,300 kilowatts, and then we converted that to BTUs and got 15 million BTUs per hour. That's $100,000 to get our school monthly.
We came up with different ways to save money by installing timers on hot water boilers, turning exhaust fans off, adjusting thermostats, maintaining equipment, and in our opinion, if the building was better insulated, there could be substantial savings. Due to the recent renovations to our school, we found no outstanding environmental issues.
After careful analysis of our investigation, we constructed a survey that we handed out to students and staff. The survey included questions such as, do you shower after gym or any sports activities? They all answered no.
This is how our domestic hot water is heated. The boilers in our school are old and not too efficient.
Some solutions to the problem is that we could retrofit our old boiler with a vent damper, and
The cost of that retrofit is $180 plus labor, and it's very easy to install.
this is an example of a power vent damper, which will cost you approximately $155 plus labor. What this does is stops heat from being wasted from the chimney.
Our second option is an Alpine condensing wall mount water boiler. It costs approximately $4,633 plus labor.
So out with the old and in with the new, our old boiler is 75% efficient, and if we were to get another one, it would be 95% efficient.
The school's annual cost for domestic hot water is $7,050 per year, and if we retrofit our existing boiler, we can save approximately $1,058 per year. And if we shut off the hot water boiler for 12 hours a day, we can save $3,500 annually, and if we replace the oil boiler with a higher efficiency boiler, we can save $1,863 a year. That's approximately $5,363 a year.
Hey, you know, I like your ideas. You guys are very smart. You seem like you know what you're doing. You know, as I always say personally, out with the old and in with the new, eh, Augie?
What are you doing, yeah? What are you trying to say? No, you're trying to say I'm old, you're trying to get rid of me, yeah?
You're too suspicious.
All right. Anyway, there you have it, folks. Single stream recycling, we need to be more efficient with the energy, save water. Bada bing, bada boom, forget about it. We're done.